Hello, my name is Seth Davis, and today I'll be presenting Enterprise Information Systems and Manufacturing. So, as an introduction, manufacturing is the process of converting raw materials, parts, or components into a finished product. And there are five key aspects of manufacturing: there's design, production, quality control, supply chain management, and technology and automation. So, design is the planning of the product, such as what you want to make, how you want to make it, and every other aspect that goes into it, such as raw materials and every other process that are associated with it. Production is the actual producing of the product using the materials, uh, the components, or the parts. Quality control is testing to see if products meet the established standards. So it's to test and see if your products withstand up to any test, any physical test, any quality test, any visual test that you put up against. Technology and automation are the technologies that make up the manufacturing process, such as the actual conveyor belts, the machines, any dies, any kind of presses, anything like that that's actually making the products. So, information systems. Information systems are systems designed to collect, store, and process data. And there are five components of information systems: there's hardware, software, process, people, and data. So, hardware are the physical components that make up the information system, such as the computer or any kind of sensor that'll be collecting data. Software is the actual software that's being used, such as like an ERP or an MES system. Process is what the information is actually doing to collect, or the information system is doing to collect this data. People are the ones that are working or using the information systems, and data is the actual numbers and other analytical objects or just readings that are being collected to be used. So let's just go over a little bit of history. So the history of data and technology in manufacturing. So when you think of manufacturing, you always think of machines or robots or anything like that. So even back in the day, data and technology go hand in hand with manufacturing. So manufacturing dates back to the late 18th and early 19th century with the Industrial Revolution. The creation of steam and water-powered machines actually really fueled the startup of manufacturing. Um, Now back then, data was kind of not very it's not really collected in as far as like the manufacturing process. It was more just like, oh, we need this many made, so let's produce this many and try to do it within this amount of time. There wasn't a lot of data being collected to figure out how to maximize any kind of process or make it more efficient in any way. So it was just very rudimentary. And the very first manufacturing industry in America was actually the textile industry, which was in 1790. And that was actually the cotton spinning mill that was in Pawtucket, Rhode Island. So, in the late 19th and early 20th century, mass production boomed. So, as we all know, there's one particular man that really hit the market and hit the news was Henry Ford. And because he was so famous because of his creation of the assembly line. Well, he didn't actually create the assembly line, but he's the one that popularized it, especially here in America. And what he saw is with the assembly line, he actually had higher efficiency and lower costs because all these cars that were being built were on a continuous moving track. And so you had to keep up with the track in order to finish the car and do your job and get to the next one. Otherwise, the car would be unfinished. And because the track was continuously moving and people had to keep up, there were standards set and they were collecting data on how fast they could actually go and how much they could actually produce. So by the mid 20th century, computerization and automation began to be used in manufacturing. So computers have been here for a long time. The first one was created in the late 1800s, but computers didn't get used necessarily in industry or in manufacturing until about the 1950s, 1960s, just because they were not accurate and they were just bulky and not really good. So, in the 1950s and 60s, commercial computers were being used in manufacturing. And that's what actually allowed for the first implementation of information systems. So in the 1960s, the first information system used was Material Requirements Planning, which is or MRP, and this was an early inventory management system, as well as a production process manager. So it helped them with supply chains, it helped them with raw material gathering, ordering parts, also just processing times and any other simple data such as like how fast something's being produced, how much is being produced, simple things like that. Again, they didn't have as many sensors or uh, check lights or anything like that we have today, but they did have a pretty good and solid system back then that helped them to become more efficient and have more tabs on what's actually happening in their process. So from then on, actually, information systems were used in manufacturing. Um, so back then, uh, what was also being used and considered information systems were CNC and PLC. So CNC or computer numerical control, which actually uses a computer to change and do math functions to actually cut down a block of metal or any other products. I think back then they only used metal for CNC to create a product. And PLC is programmable logic controller, which is a controlled manufacturing machine system. And they can control different processes. They control machines, conveyors, anything like that from a computer system. Uh, in the 1970s and 1980s, information systems were being mass introduced into manufacturing. So as previously stated, we had MRP. So MRP was the first one used in the 1960s, but it gained traction amongst other industries and manufacturers in the 70s and 80s. And actually, the MRP got changed and transformed into MRP2, which is Manufacturing Resources Planning, which is a more efficient one. Um, in the 70s and 80s, these information systems helped manage production schedules. They helped with inventory levels, supply chains. They helped to increase operational efficiency, and they, more importantly, helped with decision making, which decision making actually sort of ties into all the other previously stated factors. Now, in the 1990s, there was a rise in enterprise systems. So we had the rise of ERP, which is Enterprise Resource Planning. And ERP actually integrated manufacturing, finance, HR, which is human resources, and supply chain management all in one. And Industry 4.0 was introduced after the 1990s, which is the 21st century. So this is a new era of data-driven manufacturing that use smart systems, robotics, AI, anything that you can think of new that's kind of astounding, kind of like robotic-y in any way. That's Industry 4.0. And what's also under Industry 4.0 is IIoT, which is the Internet of Things, data analytics, and cloud computing. So the need for EIS. So as manufacturing got more complex, there was a need for information systems because there were more processes happening at the same time. And obviously, you can only have one worker looking at realistically one thing, one physical thing at a time on a process. So these information systems were needed to monitor multiple aspects of a process on one screen. And that's what allowed the operator to actually keep eyes on all different aspects of the process, not just one. And since the induction of the first IS, manufacturing has relied on them heavily. Just about every single manufacturer and system has some sort of information system. Hold on one second. Testing, testing. Okay, good. Sorry about that. My headphones died. All right, so the need for EIS. Yeah, so complex production lines, they need the information systems to monitor steps, values, and errors. And businesses actually started using them because they were also losing money due to waste, as well as having timing errors, which prevented in either stuff being waited on in WIP, which is work in progress, or they just were being set out, overproduced, anything like that. And they also had supply chain errors that were also happening, such as not meeting demand out in the world, or they were overproducing something when the demand was really low. So types of data collected. So information systems collect three different types: production, machine, and quality. So in production, what they measure is quantity, so how much they're producing; rate, which is how fast they're producing; and the efficiency, which is just overall like how well their timing and their actual production is. So machine data collected is like status, downtime, and operating conditions. So this falls under like what, or this overcasts like anything that the machines are actually doing, like how fast they're running, whether or not they're broken or not, what they're producing, how much they're producing, anything like that. And then finally, there's quality data, which is the measurements of the actual products that they're making, any defects that are being produced, any deviations in their quality of products. That's all the data that's being collected there. And on the right is actually a pyramid that goes from basic data to tactic knowledge on these different information systems that are out there. So they have transaction processing systems at the bottom and executive information systems at the top that have a bunch of data that's being collected and different processes being monitored, where at the bottom there's not as much data being collected and maybe like a few processes being monitored. So it gets more complex at the top and less complex at the bottom. So impact of IS in manufacturing. So information systems play a major role in manufacturing. Like I said, everything that has a process in manufacturing right now does have some ties to information systems in one way or another, because you can't have any kind of automatic system or automation without some kind of data being gathered to let you know that the process is running smoothly, running accurately, anything like that, and that requires information systems. So information systems have been a major role. They're everywhere. They've increased operational efficiency by let you know which factors you need to change in your process to actually achieve better output, better quality output, faster output, anything like that. So improved product quality. Information system can provide data such as like if it's a chemical compound, you can change the actual makeup or portioning of each ingredient to get a better quality out. Or you can use information to test and see if there's any deviations in a product. And if there is, you can kick out those bad ones and only let out the good ones. Faster time to market. Because the information systems provide a lot of data about timing, you can actually have a better idea about when your product can actually get out of the facility. And so you can actually have people that order ahead to get the products on the floor faster, sooner, and then get them shipped out in time before like a company runs out of what's in stock. And decrease production costs. That's a big thing with the information systems, as you can see how much waste you're producing. You can see how many defects you're having, and because of all this data on like what's going wrong in your process, you can change those little factors to fix all the issues, so you can, one, not have a lot of waste from just products that can't be recycled or can't be sold, but also you can just change little factors so you just immediately have everything being produced perfectly. And time is money, so any time down with a machine is money being lost. Improved safety. Information systems provide a lot of safety factors because they have a lot of error codes, and they have alarms that can go off. They control all these alarms, and they relay information about alarms, any process failures, anything like that. And like on the right side, that's a picture of a car being manufactured with a bunch of robots. Robots do not have feelings, and they definitely can't see you. So if there's a problem with one of those robots, and you definitely don't want anyone going near it, so it's good to have an information system that will relay that there's an error with one of those robots, so you can shut it down remotely before someone goes and operates on it or just walks by it just to check it out. And improved decision making. So information systems provide a lot of data, and without data, you can't make any kind of decisions. So this increase in data and knowing like what's actually going on in your business, you can make little bitty changes and you can sway about what you actually need to change. So your overall decision making is improved. So here's one example of a information system that's used in manufacturing. It's called Oracle NetSuite. So this is an ERP system, and it's cloud-based, and it has a bunch of integrated modules within it, such as financial management, inventory and supply chain management, CRM, HCM, PSA, and e-commerce. Now, just to go over it, CRM is customer relationship management and human capital management for HCM. So Oracle's NetSuite, what's good about it is it relays real-time data, so you can make quick on-the-fly changes or just monitoring and know exactly how your system's running. It can be used globally because it can actually, with the financial sides at least, it can actually do money transactions with different currencies. And also because it's cloud-based, you can work on this system globally from different areas of the world. And finally, this has a lot of third-party connection that's available for it. So you can connect to any kind of machine, data source, JavaScripts, any kind of different coding, and you can monitor your whole system and not have to worry about, oh, is this information system actually going to work with my specific setup? So it's very versatile. So here's an article that I found that discusses the Internet of Things in information systems. And the title is Internet of Things for Enterprise Systems of Modern Manufacturing. And in this article, they actually have a few examples of the Internet of Things that they were using. They were using wireless sensors and DACs, which are data acquisitions. And that just gathers data. So after reviewing the article, I made the assumption that it's actually very popular in manufacturing information systems. The use of Internet of Things is. With the Internet of Things, which is the connectability over Wi-Fi of different devices, you have enhanced data acquisition because you don't have to worry about running wires specifically from a sensor to a module to read. It can do it over Wi-Fi signal. So you can get into smaller, tighter areas. You can have a better sense of what's happening in your process because you can put more sensors in more places. The use of this is actually, in the article, it actually reduced the downtime of their machines because these wireless sensors and these DACs that were taking all this data were relaying enough information back saying, oh, there's a problem, it needs to be fixed now, rather than the machine running with a problem for a while and then someone finally noticing later just based off of either walking by it or seeing that the products are bad. So it had enhanced product quality because of that as well, and enhanced decision making because it allowed them to have more information on the subject or the matter and make quick decisions. This other article I read was an agile information processing framework for high pressure die casting applications in modern manufacturing systems. And in this article, they actually discuss the inline data mining that is used for their die-cast manufacturing. And data mining is another type of information system. So with the data mining, they are actually, like it says, mining data in their die-cast machine. And so they're continuously getting data on what's happening. And this data is actually being visualized on interfaces for the operator to see. And because it's being reported back to an interface to the operator, it was a higher knowledgeable operator that was working more efficient, could respond to any kind of change better, and they just had improved decision making overall. So yeah, it provided knowledge about processes that was easily accessible and provided good reports, and it was a visual screen that displayed all this information, so it helped the operator to make decisions. So to conclude, enterprise information systems are a super important aspect of manufacturing They've been used for years back to the 1960s, and they will continue to be used in the future. They provide many benefits such as real time data, improved decision making, efficiency, lower costs, and process optimization, as well as many other benefits that I can't even list because the list just goes on and on. The reason information systems are so important is because information is the key to successful outcomes. If you don't have information on a subject, you can't alter what you're doing or know how to alter what you're doing in order to make up for the shortcomings or just have any kind of report back that what you're doing is correct. So after doing my review of information systems in manufacturing, it's my understanding that I need to understand how information systems work, how to use them, when to use them, because it will allow me to be successful in the near future whenever I do get a job, because they are going to continue to use information systems, and if I can understand them, then I can take advantage of them and use them successfully to my advantage. As technology advances, information systems will most definitely advance, as we can see with the history. The information systems just kept getting more and more complex with the use of Industry 4.0. AI is now starting to be used in information systems. It's not like set in stone that they're being used, but they are talking about using them. They're experimenting with them, and in the near future, I'd say probably 5 to 10 years, we're going to see AI in just about every information system. So EIS are a near permanent aspect of manufacturing, and they will continue to grow. And so I will need to be on that side of understanding information systems to better myself, to better the company, and to better keep up. And here are my references. And thank you for listening.